Hello, our fabulous chemistry minions.
Time is passing. Are you?
Ooh,
Ah.
Oh, Gotti.
So we are in our fourth video, page 6 in our pack. We're going to get into our details on our first hydrocarbon series.
So let's start easy. Let's start with straight chains. Let's not get all crazy.
No double bonds or triple bonds.
Call them alkanes.
Alkanes.
What on earth is an alkane?
Oh, it's an aliphatic chain
Here we go.
of carbons
Here we
that
go.
is saturated with hydrogen atoms.
You just can't help but answer questions when they're asked, huh?
I can't.
All right. All right, so basically they consist of just carbon and hydrogen.
Yep.
Hydrocarbons.
Hydrogen, carbon. It's in the name.
Saturated, only single bonds. Basically, this carbon chain is going to having the minimum number of bonds helps us have the maximum number of hydrogen atoms to bond with. Remember, carbon makes how many bonds?
4.
So if I start using up those bonds between carbons, that's less room for hydrogen.
Well, and as I said in this video, we're only going to link our carbon atoms to other carbon atoms by one bond here,
True. Well, that will eventually be the name of alkanes.
leaving all the extras to make hydrogens, just like in this picture. This is perfect.
So this is going to be our example for how we name these bad boys. We're going to use this guy and not tell you what his name is. We're going to use the reference table to figure it out and model it.
Exactly
We're gonna
like yours
practice
guns to halves to do's.
Right.
So let's hit it.
You don't got to draw it this big. I know you don't maybe not have this much room, but you do have to draw this structure in here somewhere.
Yep.
You can be kind of small, and here we go. So first thing we got to do, right?
Look and find the prefix for the name, because it's going to tell us how many carbons are in the molecule, and that find them on table P.
Right. Oh, we didn't hit this before, but let's just hit this up right now. This system for naming is cool. In the fact that it goes forwards or backwards.
Right.
Once you learn it, you can draw the molecule from the name or come up with the name from the molecule.
Right.
Right now, we're going to come up with the name from the molecule.
For sure.
Okay?
My analogy is that I love things in life that are named after what they do. A backpack. Well, it's a pack that you put on your back. You know exactly what it is.
Right. Well, guess what? These are going to all be that way.
Mm-hmm.
They're all going to be very explicit.
Mm-hmm.
So let's check it out. Ready? There's 1, 2, 3, 4, 5,
6
carbons.
carbon.
So I'm going over to table P to where I see 6.
And the prefix to use for this
Hex.
molecule's got to be hex. So whatever its final name is, it involves starting with hex.
Right away. So if I'm going backwards and I see the hex, I know 6 carbons.
Right. And we'll show you how that's done soon.
Yep. Okay, so next, the root tells us the bonding.
Okay.
We check that out on table Q.
Q. So you look at table Q and you see, okay, I know I've got 6 carbons, but are they all connected with singles, doubles, or triples?
Right. And we look.
That's
highlight.
all singles, single bonds.
So that's an alkane.
So the ane, A-N-E, becomes the end of the name.
Correct. The ane comes over, and the name of this bad boy is hexane.
Hexane. Cool.
That's it.
I know of a hydrocarbon that you might see all the time at the gas pump.
Octane.
Octane. How many carbons would that have in its chain?
Let me go back.
Oct. Oct means prefix oct dash. That's 8 carbons.
It is.
So I could draw 8 carbons in a row, connect them all by single bonds, because it's ane, and then fill it all up with hydrogens, and you have the molecule that makes your car go.
Right. And then the 91, 89, 93, that's all based on like percentages.
Yeah,
of
it's
how much
actually something else,
Well,
but
it's close.
it's a number rating to see. Yeah, but let's get into the actual work here.
All right, so you do one, and then I'll do one.
Okay.
Or actually, you do 2, and I'll do 2, because that way we go both.
I have in my hand my reference table, because we're not going to flip that up
I'm
every
going to
time.
talk you through, because I'm sick.
Yep.
You do it, and I'll talk you through. Here we got the name. We got to draw the formula. We're going to use the same thing. So first I see meth. I look up on my reference table. Meth is how many carbons, Mr. MoNaCo?
1 carbon.
So I'm going to draw 1 carbon. And then it says ane, so it's single bonded. But guess what? There's only 1 carbon. So I'm going to surround it with hydrogens.
I'm going to surround it with 4 bonds first.
Well, yeah.
Right, because carbon always does 4 bonds.
And
You
then
go north,
it's
south, east,
ane,
west.
So it's a saturated carbon, so it's going to have all hydrogens.
All hydrogens around, yeah.
Now, first video we talked about molecular formula. We can write this now. I see a C and then 4 H's, so let's do H4. That is the molecular formula, and it is saturated because it is a alkane.
Right. All single bonds. There's no doubles.
Okay, so now this next one, Mr. MoNaCo, you got to go backwards.
Backwards.
So let's start with number of carbons. I see 2, so look on my chart. How many carbons do you, look up 2 carbons on your chart and tell me what name you see there.
The prefix for 2 carbons is F.
F, so I know the name's going to start with an F. Okay, now I'm going to look at the bonding between the carbons. I see it's single bonds.
And I look at table Q.
And I
All
find the
single
molecule of
bonds
single
are
bonds.
alkanes, so that would be ANE.
A-N-E, ends in ane, F-ane. Now we got to put in the H's for our molecular formula. Count them up. I see 6.
Okay,
Is
and
it saturated?
well, it's an alkane. It is full of hydrogens. It is saturated.
There you go.
And I can double check on my table Q. I see that there's a formula.
Oh, you want to go right down to that formula, please?
Might as well, real quick,
Okay.
and use this as an example. C2H6.
Okay, so what that means is the N is the number of carbons. So if I have 2 carbons, that gives me a C2. Now, I don't know the molecular formula per se, but if I plug that in, the 2 for N, I get 2 times 2 plus 2, which is 4 plus 2, which gives me 6. So if my molecule was C2H6, it would be an alkane that is saturated. And just look at it, the molecular formula we got is the same, C2H6.
And that is only going to come into play if I give you the molecular formula telling you nothing else
Yeah,
and
is
say,
it saturated
hey,
or not?
is it saturated or not? You have to go back to table Q and plug that formula, and off you go.
Right, it's a way to do it without having to draw it.
It's a way to do it when you're limited on information like structural formula and name. If
Right.
you're just given the molecular formula and you got to figure the other 2 out, you got to go and use that molecular formula from the hydrocarbon.
All right, so I'm going to do the board. You talk me through it.
Propane. Prop is the name. So I look at table P. Prop prefix
I find
is.
prop, and it says the number of carbons is 3.
So draw 3 carbons connected together. Cool. ANE means it belongs to the alkane series.
So that means these single bonds stay. I'm not going to make any double bonds.
Now you got to fill up carbon with all 4 bonds around each. So the left, middle, and right carbon have all 4 bonds. Yes, some are being shared, but that's what covalent bonding's all about. He's filling up the rest with hydrogens, so you can then figure out the molecular formula. C3, H, he could count,
6, 7, 8.
or he could apply the molecular formula, 2 times 3 plus 2, 8. So it's
And it's
saturated.
There is as many hydrogens as I can possibly stick on that bad boy.
Absolutely. Last one. He's got 4 carbons in a straight chain. So he's going to look up on table P prefixes. 4 carbons means
It says but.
but. But.
But.
That's fine. The root. So the prefix is BUT.
Right, you and I know that's but, but they're not going to at first.
Now he can look and count the molecular formula. He can go C4, H. He can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4H10. So then he can go look at his table Q.
4
H, 4 times 2 is 8 plus 4
plus
2
is C4
H 10. So it fits the molecular formula for all alkane types
So that ends in ane.
because it's an alkane. Okay. Now the last little thing we got to do is tell you a little bit about the structural formula.
One little thing.
You got to look at the bonds between carbon atoms. All of them are single bonds, therefore it is an alkane. We also taught you how to apply the molecular formula to the general formula from table Q to figure out if it's an alkane also.
Yeah, this structural formula piece really is a shortcut.
Right. If you have a picture to look at,
Go with it.
go with it. But sometimes you'll just get a molecular formula.
Right, and you can do it both ways.
Try and draw it out,
Yep.
or go apply the general formula, and you're probably good.
Right. whatever works for you.
So, we want you to be able to recognize, name, and draw alkanes, the simplest hydrocarbons.
Guess what? There's practice.
There's table P to help you find the carbon backbone.
That carbon backbone is, by the way, by definition, the longest carbon chain I can pull out.
Right.
In this case, real simple.
We'll show you how that works when we're looking at branched
it'll get
hydrocarbons.
crazy.
So that's your prefix. Use your P, table P to find your prefix.
Table Q and or structural formula to get the series name or that root. Is it an ane?
An ene or an ine. We're going to do enes and ines in the next video. This was just alkanes.
Right. Well, when we jam them all up and make you go, make you figure it out. That's what you're going to have to do.
And I guess the biggest asterisk is you got to memorize that alkanes are saturated with hydrogens.
Right.
Because that is nowhere in your reference tables.
Correct. And what that means is it physically cannot hold any more hydrogen.
All the carbon's bonds are full up with bonding to other carbons or hydrogen.
Right. Well, specifically holding as many hydrogens as it can. So it's all single bonds with the carbon.
Right. So that's why I said
double and triple.
that's why I said a carbon could be bonded to another carbon, because
Could
that's
be.
just like default. Okay.
Yeah, yeah.
So thanks for watching. A couple more videos to come.